Hello and welcome to Maths. My name is Alex Rogers. I'm Key Stage 5 Coordinator of Maths here at William Hughes. Okay, I'm going to tell you a little bit about the Maths course that we do in a little bit. The first two questions: why Maths? Why William Hughes? Why Maths? Because Maths is everywhere. The only way we have of describing the world in an objective, quantitative way is using mathematics. You might think maths, engineering, physics, but it comes up all over the place. In M13 we've got a series of posters where you see maths in archaeology, in politics, in ecology. It comes up all over the place. Okay, so that's why maths. Why William Hughes? Well, we've got small class sizes. Our average class size here is less than 10. Our average size of the year is around 30-35. So I know all of the upper six as individuals. They're not just pieces of data on a table for me. I know them as individuals. Maths teachers, well, I've been teaching here for nearly 20 years and I'm not even the most experienced member of the department. I'm about third. We've got 8 teachers here who teach Key Stage 5 in one form or another, and 5 of them at one time or another have taught further maths. So we've got a lot of experience here and a lot of support. One of the things that I think is great about this place is we generally have an open door policy. So I might not teach you, but if I'm teaching a lesson, you're free. You want to come in, fine. If you want to be involved in that lesson, fine. If you want to ask about something else, as soon as I get the chance, I'll come over and talk to you about it. Whenever you want to see me, drop in, we'll have a chat. Okay. The other reason why I think we're great is because every one of us loves maths. We're the kind of people who at lunchtime set ourselves little problems. We not only love maths, we love education. We'll tell each other about, oh, I did this great little thing, this little explanation with a couple of pencils and a ruler to show moments, or I've done this experiment with dropping balls. We talk to each other about our ideas, but I wouldn't say that there was a typical lesson in William Hughes. One of the things that I think is great, there's no point having 8 different people you can speak to if you're going to get the same explanation 8 different times. You'll have different people doing different ways of explaining things. You might see me running up and down a classroom pretending to be a lobster-like alien to explain linear coding. Another teacher, you might see them, looks like they're putting together little bits of cardboard. Yeah, they're doing Tarsiers, but they're doing Tarsiers on hyperbolic equations. So lots of different ways of doing things, lots of different members of staff. Okay, right. So that's why maths, why William Hughes. What about further maths? You might not know whether you want to do further maths. It's hard to tell. Further maths is hard. So one of the things we do is the first half term of further maths, all we do is do stuff that's on the maths syllabus, but we do it quickly, and we do some of the stuff that you would only do in year 13. So if you find out, actually no, further maths isn't for me, I'm doing it as a 4th subject and I've found out my other subjects are harder than I expected, fine, you haven't lost anything. That first half term, everything you do, you need for the single maths syllabus. If it turns out that, yeah, actually that was tricky, but I can cope with it, I'm happy with it, then after half term, in the first year, we start doing the further maths material. Right, okay, we'll talk about that. What material do we do? The course we do in maths is the EdXL course. We do that because we did do the EdXL GCSE, but in terms of the single maths courses since 2017, they're pretty much the same for the different boards, so there isn't much different between them. What I think is nice about the EdXL one is the large data set that they use is a more interesting data set than some of the other exam boards. Single maths is split into pure and applied. The pure, the main thing we're looking at A-level is how do we deal with things that are changing, how do we deal with things that are curved. A lot of GCSE, because it's GCSE, because we're starting off, we deal with straight line relationships. What do we do when things are curved, when things don't go the same way? What do we do when systems are changing throughout time? So we do a bit of a recap of your standard algebra, we do a bit of a recap of circles and geometry. Then we have a look at trigonometry, which is mainly focused on triangles. But actually trigonometry isn't about triangles, it's about how angles relate to lines. So we can deal with curves, we can deal with angles beyond 180, beyond 360. We can deal with systems that oscillate backwards and forwards with trigonometry. So there's a lot more power in there than we might not have realised. As already mentioned, rates of change. One of the big things about A-level pure maths in year one is having a look at calculus. How you deal with systems that are changing through times. Two big topics there, integration and differentiation. The other part of A-level maths, that's applied maths. So that's split into two sections, statistics and mechanics. In statistics, we have a look at samples and populations. How, if we want to tell about the whole population, do we need to gather data from that whole population? Can we gather data from the whole population? What do we do when we're restricted in the way we can sample data, and how does that restrict our conclusions? We also have a look at probability. If we can't sample things, can we theorise probabilities about the way that systems work? We also have a look at a thing called hypothesis testing, which is testing the significance of the information you've got. In mechanics, we have a look about kinematics, things in motion, we have a look about forces, and we look at variable acceleration, where we have to use the calculus I was talking about from the pure maths. Further maths looks at a few other things. We have a look at complex numbers, where we're including real and imaginary numbers. And bizarre, even though mathematicians invented imaginary numbers as an intellectual exercise, they've got loads of practical applications, from impedance in oscillating circuits to measuring black holes. It comes up quite a lot of the time. Matrices is another thing we look at. We have a further look at vectors. We do a little bit of vectors in single maths. We have a further look at vectors, and we do scalar product. And in the further maths, we have applied options. In normal maths, you have to do set applied. Further maths, we suggest in year one you do statistics and mechanics, which builds on the statistics and mechanics from single maths. But in year two, you could either go on and do more mechanics, you could do more statistics, or the other suggestion we make is that you could do an algorithms option. Because we wanted the choice in options in further maths, we went for the NEI OCR board for further maths rather than sticking with the Excel board. Okay, I hope I've answered some of your questions, hope I've encouraged you to come to William Humes, and maybe I'll see you next year. Thank you.